what does anyone want to describe what the equilibrium of that situation would be? Yeah, Jacob.
The price the firm's charging would have to be their cost.
Why?
Because otherwise, you could undercut the other firm and steal all their customers.
And why would you want to do that?
Because then you're charging a price still higher than your cost, so you're making profit on those.
Exactly. So rather than splitting the customers or not getting any, I can get all of them if I just charge a tiny bit below his price. So why not do that, right? Only once we've been driven down to cost do I not have an incentive to do that, right? Okay. So this is called the Bertrand and Edgeworth paradox. With more than one firm, even if there's only two firms, we get prices exactly equal to cost. So this seems a little bit implausible to people, right? It requires that if I undercut another firm by a tiny amount, I'm going to steal all their customers, right? And I think that this seems pretty unlikely in the real world. Bob, why do you think that it's sort of implausible that if I reduce my prices just a tiny bit below other firms' prices, that I would get all of their customers?
Simply because there's transportation costs in between different stores, and also maybe customers don't care about very tiny changes in costs.
In prices. Yeah. Yeah, that's right. So usually consumers view different products as somewhat differentiated, right? One reason is some non-price characteristics to the product, where the product is located, as Bob said, or what color the product is, what flavor it has, et cetera. And another reason is products could be pretty close to identical, but consumers might have to search for them. So one firm might produce its price by 1 cent, but it might take too much work to figure out what the prices of the firms were, that it wasn't worth doing that, right? In either way, we can write the demand for a firm's goods as a function of the price that they charge and the price that all the other firms charge, right? And in the Bertrand setting, if I reduce my price by $1 below the other guys, suddenly I got all the demand. But more generally, you wouldn't think that that's true, right? You would just think that the products are substitutes for one another. That is, if the other firm increases its price, that will raise the demand for my product, right? Partial QI, partial PJ is greater than 0, right? Now, this is a very broad model. We don't have to view prices as the strategic variable here. I don't have to take other firms' prices as given. I could take their quantities as given, and similar logic would be the case. My quantity would go up when other firms reduce their quantity typically, because that would increase the demand for my product, right? But the most standard assumption is that we have what's called Nash and prices, or Bertrand. So this model is called differentiated products, Nash and prices, because the products are not perfectly substitutable for one another, but firms take each other's prices as given. So let's go back to, the simplest example of this was the hoteling model, not from last class, but from a few classes ago. And rather than being in the middle, let's imagine that the two firms are at the ends of the hoteling line, right? So one is positioned at 0, one is positioned at 1. And a consumer located at position X has to choose either to buy from firm 0 or to buy from firm 1, right? And they're going to buy from firm 0 if the amount that it costs them to get to firm 0 plus the price they pay for firm 0 is less than the amount that it takes for them to get to firm 1 times the price that they pay for firm 1 plus the price. Yeah. So the amount that the cost of getting to firm 0 is the transportation cost times how far they are from firm 0, that's their position, plus the price, versus how much it takes to get to firm 1, 1 minus x, plus the price of firm 1. OK. So Israel, can you solve for the optimal for the value of x, where someone would be just indifferent between going to firm 0 or to firm 1?
You would set P1 minus P naught plus T equal to 2tx.
Yeah. So divide through to figure out the x, right?
So then x would be equal to p1 minus p naught plus t over 2t.
Yeah, exactly right. And everyone to the left of this, where are they going to shop?
At 0.
Yeah. And everyone to the right is going to shop at 1, right? OK. So the demand for firm 1's good, then, is just the number of people who choose to shop with them, right? So that is sorry, I switched from 1 and 0 to 0, 1 and 2. Sorry about this. So this is the demand for firm 0's goods, right? So this should be 0 as a function of P0 and P1 is that. OK, so notice that this is just linear demand, right? As a function of my price, my quantity falls linearly, right? Now, if my cost is equal to 0, Jing, what would be the optimal price for me to set? Don't look at your slides. What would be the optimal price for me to set if my cost were 0?
So if the profit is, if the cost is 0, the profit is the P0 times the quantity. That is,
Yeah.
that's so you take the
But you don't even, you can go through that if you want to go through it. But remember the trick we learned. When the cost is equal to 0, where do you price on a linear demand curve?
And so it's halfway through the
Exactly. And what would halfway through be here?
the so when P naught is 0, so it's P1 plus T over 2T. So
Exactly.
it's
It's plus P, it's when P0 is equal to P1 plus T, then there's no demand, right? So you do halfway to that point. So you do P1 plus T over 2, right? OK. So then what's going to be the equilibrium in this market, Clemence? So we know that my optimal price is a function of your price is this. So how do we solve for the equilibrium?
Your price is a function of my price.
Yeah.
That is 2p0
Minus t? Or? OK, so this is the optimal price for 0 is a function of price 1. What's the optimal price for 1 as a function of 0? It's got to be symmetric, right? Because the firms are symmetric. So how do we solve out for the equilibrium?
p0 equals p1 equals t.
Well, if the firms charge symmetric prices, right, then we can just plug in P in both of these places, right? Because at equilibrium, they charge the same price, right? And then we can just solve for P. So how would we do that?
So it's p1
Yeah. Yep. Exactly. Exactly. OK. What about if there were positive costs? George?
So if there were positive costs, would you just be adding the term C, if it was positive, to the optimal price equation? P1 plus T plus C over 2?
Exactly, because the pass-through rate under linear demand is 1/2, right? OK, so then each firm would do this, right? And so we just have T plus C, so every firm would set their price equal to T plus C. So the overall pass-through is going to be equal to 1. And the reason is because no consumers exit this market. The total market demand is not It doesn't have any elasticity. Everyone buys from one of the two goods, right? So this is just an example. In a more general thing, we could solve the two firms' reaction functions. Here we could just use symmetry and use the fact that the prices were the same for the two firms. Okay. So the same basic principles apply more broadly. We can define the residual elasticity of a firm as the elasticity of its demand when it holds fixed the prices of all the other firms. And Kay, what would be the mathematical expression for that?
So, the elasticity of demand holding other fixed.
Yeah.
So, we want the derivative of quantity with respect to price, like divided by quantity.
Yep, but what type of derivative? Exactly, because we're holding fixed all the other firms' prices, right? Absolutely. So yeah, the elasticity is exactly what Kay just said. And then we will price according to the Lerner rule, but the elasticity that we use is now this residual elasticity holding fixed the prices of other firms. So the same basic monopoly logic is still true. It's just that we need to define my residual demand curve and its elasticity, the demand curve holding fixed other firms' prices, right? And there's nothing special about prices as strategies, right? If I hold other firms' quantities fixed, then I'd want to say, well, what's the elasticity of my demand curve holding as fixed the quantities of other firms, right? So basically, for any game theory problem, you can always think of each firm solving a monopoly problem holding as fixed whatever it takes as the other firm's strategies, right? Okay. Now, oligopolists create externalities on one another. And why is that, Charlie?
Just by like lowering the prices.
So how would lowering the price help or harm another firm?
So the pecuniary externality we discussed in the previous lecture was that by lowering the price, you're stealing a portion of the sales. And
That's a real externality, right?
oh, right.
But yes, that is an externality.
Yeah, yeah.
What's the other effects that I could have? What's the pecuniary externality I might have?
That you just lower profits, like.
Well, you lower prices, right?
Right. Yeah.
Right? So that's a pecuniary So if I do something in a market, I could lower the prices to other firms, or I could lower their quantities. That when I lower their quantities, that's a real externality. When I lower their prices, that's a pecuniary externality. Now, under Cournot, all the externalities are purely pecuniary on the other firms. And saying, why is that?
Because in Cournot, you're thinking the other's quantity is fixed.
Yeah.
So the only effect you have on others is the price.
Exactly. Now, under differentiated products, Nash and pricing, the externalities that you have on all the other firms is purely real. There's no pecuniary externality. And why is that true, Clemence?
Because the contrary prices are fixed, so we charge our quantity, so no quantity change.
Exactly. So that means that under Cournot, quantities are always going to be too low. And the reason that that's the case is that we already know from monopoly, that when you increase your quantity, that brings a benefit to the consumers that you don't internalize. But there's no real externality to offset that on the other firms, right? That's all the effects are just pecuniary. So there's just this one externality. But under Bertrand, could it be the case, Chairman, that there's too high quantities when you have differentiated products, Nash and pricing?
What was the question?
If under differentiated products,